July 2025, astronomers spot something racing through the solar system, faster than anything bound by our sun's gravity. A blur of light, distant yet deliberate, cutting through the blackness. At first, they thought it was another comet. But as the data came in, one thing became crystal clear: this wasn't ordinary. This was 3I/Atlas, the third interstellar object ever discovered, and now, it's rewriting everything we thought we knew about cosmic visitors. The story begins on July 1, 2025, when the Atlas telescope in Chile picked up a fast-moving object that didn't quite fit any known pattern. Follow-up observations confirmed it wasn't orbiting the Sun, it was passing through, following a hyperbolic trajectory. That means it came from outside our solar system. Just like Oumuamua in 2017, and 2I/Borisov in 2019, this was another traveler from deep interstellar space. Unlike Oumuamua, which was oddly shaped and behaved more like an asteroid, and unlike Borisov, which behaved like a traditional comet, 3I/Atlas didn't quite match either. Early size estimates put its nucleus at about 5.6 kilometers across, making it larger than Borisov, but its mass was what truly stunned astronomers. When comets warm up, sunlight causes frozen gases to vaporize, releasing jets of gas and dust that act like tiny thrusters, gently pushing the comet off its predicted path. In most comets, this non-gravitational acceleration is measurable and expected. But with 3I/Atlas, things didn't add up. Despite showing clear outgassing activity, the comet's trajectory hardly changed. Its deviation from pure gravitational motion was less than 15 meters per day squared, an incredibly small number given how active it was. Even Borisov, which behaved like a textbook comet, was dwarfed by this interstellar giant. This sheer mass made 3I/Atlas one of the heaviest interstellar visitors ever recorded, and instantly raised new questions. Astronomers use the word anomaly carefully. They don't mean it's unnatural, they mean it doesn't fit the models. Current theories suggest that interstellar space should be filled with tiny fragments, the leftovers from planet formation, debris ejected from young systems. So the odds of detecting a large, 5-kilometer wide object so early are incredibly slim. Oumuamua, Borisov, and now Atlas, all relatively large, all appearing far sooner than probability suggests. This raises an uncomfortable question. Are big interstellar objects more common than we think, or have we somehow missed thousands of smaller ones silently passing by? If the size didn't break the rules, its chemistry certainly did. The James Webb Space Telescope took aim and found something unexpected: extremely high levels of carbon dioxide relative to water. That ratio places 3I/Atlas among the most CO2-rich comets ever observed. Even at huge distances from the Sun, ultraviolet instruments detected water vapor, meaning this thing was venting material early, before solar heat could even reach it fully. And then came the biggest surprise. Light polarization studies, which measure how sunlight scatters off dust, showed a distinct signature unlike anything seen in our solar system. It hinted at a different dust composition, possibly even different physics at work in its formation. Some datasets even suggested traces of nickel without iron, a combination almost unheard of in natural space materials. If that's verified, it could mean 3I/Atlas formed in an environment with unusual chemistry or magnetic conditions, somewhere utterly alien. Harvard astronomer Avi Loeb, known for his bold ideas, suggested that if the mass and composition data hold up, natural explanations might not be enough. Meanwhile, NASA's Tom Statler offered a more cautious take. It looks and acts like a comet, he said. But its anomalies force us to ask, are interstellar comets bigger than we expect, or are the small ones hiding from us? It's a fair question, because every discovery so far seems to break the rulebook. As debates continue, one thing's for sure: 3I/Atlas's story isn't over. In late September 2025, the comet's path brought it dangerously close to a solar storm, a coronal mass ejection, CME, from the Sun. If that CME did collide with the comet, we might see a dramatic event, its iron tail breaking or twisting, just like Comet Encke in 2007 when a CME snapped its tail clean off. On October 3, 2025, NASA's Mars Reconnaissance Orbiter is scheduled to use its high-rise camera to capture the most detailed images yet of 3I/Atlas as it swings near Mars's orbit. Then, it will disappear behind the Sun for several weeks, entering solar conjunction, a cosmic blackout. But in December 2025, it will re-emerge, brighter, more active, and ready to reveal its secrets as it passes the sun's full glare. The next major player in this unfolding mystery is the Vera C. Rubin Observatory. When it goes fully online, its ultrawide camera will survey the sky night after night, detecting faint moving objects with unprecedented precision. If our models are wrong, if interstellar space is teeming with these hidden giants, Rubin will find them. And if 3I/Atlas truly is the first of many, we may be on the edge of a new era in astronomy, one that finally reveals how crowded our galactic neighborhood really is. Now, with 3I/Atlas, we're realizing something deeper. Our solar system isn't isolated at all. It's part of a cosmic highway, where ancient travelers from distant stars occasionally pass through, leaving only whispers of their origin. And every time one of them arrives, they carry not just dust and ice, but questions about who we are, where we came from, and what else might be out there. So as scientists prepare to track 3I/Atlas through its next phase, remember this: the more we look up, the more we realize how little we truly know. Stay tuned, because whatever happens next might just change space science forever. If you found this fascinating, hit subscribe, tap the bell icon, and join us every week as we uncover more mysteries from the edge of the universe, from interstellar comets to the secrets hidden in the stars themselves. Thanks for watching my channel.